Section 3.3, Analyzing Graphs of Quadratic Functions. Okay, so we're going to focus in on two particular forms for writing out quadratic functions. Okay, the first one we're going to call vertex form. Okay, it's often called vertex form, although it goes by other names. And that looks like this: f of x or y equals a, which is a number, x minus h being a number, plus k being a number. Okay, so these three, a, h, and k, will all give me some kind of information about how the graph of this function looks. Okay, x, of course, is always going to be x. So real quick, though, before we go too far with it, let's kind of picture what the graph of a quadratic function looks like. And they look something like this, right? These are called parabolas. Let me try to draw a better one than that. Okay, there we go. A parabola. Okay, so they look kind of like a U shape. They could go the other way, right? They could be upside down. They could be in different positions, but these are called parabolas. Okay, something important about a parabola is that it has what we call a vertex. Okay, a vertex. A vertex is the lowest or the highest point, right? It's kind of where that graph either dips down to the bottom, or of course if it looks like this, then it's that top part there. Okay, so that's called the vertex, the very special point. The vertex can be found just by looking at the equation, okay, the function. It's the point h comma k. Now notice something, okay? This k, of course, comes from here, and h comes from here, but I'm kind of ignoring this minus sign, right? That minus sign is not carried over into the actual vertex point. Okay, so how does that look in an actual equation or function? Usually you'll see what you see written right here is the opposite of what you see right here. Okay, in other words, if this were, say, let's see if I can actually put some numbers in. If this were x plus 3, this would be a negative 3 right here. Or if this were x minus 3, it'd be a positive 3 right here. Okay, so that x value, the h value, will always appear to be opposite of what you see in the actual formula or equation. All right, so from there, that's the vertex. Another important part you might notice is, since this graph has a very special shape, right? It kind of looks, it's symmetric. Okay, let's say it that way. It is symmetric around this point here, or this axis here, this axis. So you can draw this vertical line straight through it, and you see the left side will be a mirror image of the right side, right? They're mirror images of each other because it's symmetrical. All right, so that blue line that I just drew there is when x is whatever that h value happens to be. So when x equals h, you have the axis of symmetry. Let me talk more about where the h is coming from here. X equals h. Okay, again, this is a vertical line that passes through the vertex. Well, the x value is the same throughout the entire vertical line. And where is it? What is the x value? It's h, right? Because that's the point here. This is h comma k, right? And so since the x value of the vertex is h, then h is what x has happened to be equal to. That was worded terribly. X has to equal h in order for that vertical line to pass through the vertex. That's what I'm trying to say. All right. That was a little rough. Okay. Anyway, so moving on. Now, depending on the graph, right, whether it opens upward or downward, okay, you can determine whether or not the graph has a minimum or a maximum value. Well, how do I determine if it opens up or down? Well, that's where this a comes from, okay, or where this comes in. If a is positive, bigger than 0, then the graph will open up. If a is negative or less than 0, the graph will open downward. Okay, so they both go up if it's positive, they both go down if it's negative, the ends. Okay, if it opens up like it does in this example here, then the vertex, if you think about it, is at a minimum or a maximum value. If I trace it, the lowest that my graph gets is here, right, at that vertex, and then it goes back up. So it's a minimum value. It's a minimum. By the way, that minimum value has to be k, all right? So if a is, let's do it like this. If a is greater than 0, in which case you have a graph that looks like this, that means it has a lowest point, it has a minimum. And that minimum will equal k. If you have a negative in the front, a negative a value, and the graph opens this way, then that point now, the vertex, is now the tallest point. The tallest point. So that would be a maximum value that also equals k. Okay, so that's a lot of information we can get just from looking at the graph, or looking at the formula for the graph. So let's do an example. Example 1. We have y equals negative x minus 4 squared plus 3. And I want to determine first the vertex, then the axis of symmetry, I want to determine if it has a min or max, and what the value is. And then I'll sketch the graph while I'm at it. Okay, so I'll do all those things. All right, so the vertex, easy to identify. I look at these two right here. I take the opposite of what I see right here. That's a negative 4, so I'm going to write a positive 4. And a positive 3. Of course, k just stays like it is. So 4, 3. The axis of symmetry that cuts straight through is x equals 4. Again, x equals h. So there we are again. And the min-max value, okay, well, does this thing open up or down? Well, let me sketch the graph real quick. 1, 2, 3, 4. 1, 2, 3. There's my vertex. And A is understood 1, so it's negative. Or, sorry, understood negative 1, so it's negative. So it looks like this, or something like that. Opens downward. So since this is a negative 1 in the front, my graph will open down. All right, and so that means that this point here is the tallest point on the graph. It doesn't get any higher than that. There's my maximum. And it happens to be at 1, 2, 3. When when y is 3. Okay, let's do another example. This one's kind of a trick question. I think I went too far. Let's try that again. Here we go. Y equals x squared minus 3. Okay, well, again, I want to find the vertex. I want to find the axis of symmetry. I want to figure out if I have a min or max, and what the value happens to be. Okay, and then I'll graph the function while I'm at it. Okay, so the vertex here, it looks a lot trickier, right? I have to think about this one, if I'm thinking about it in vertex form, as x minus nothing squared minus 3. They're the same thing, right? Technically. X minus 0 is the same thing as just x squared. X minus 0 squared is the same as x squared. Okay, so my vertex is 0, negative 3. That means my axis of symmetry is x equals 0. Okay, and since I have a positive 1 in the front, it opens upward. 0, 1, 2, 3. There's my vertex. It opens upward, so that's something like that. It's easy to see now that that vertex point is my minimum value, and it equals negative 3. Okay, so that's all there is to that. Let's compare that to the next example, which is very similar. Y equals x minus 3 squared. Okay, so very similar, except this time, instead of having x squared minus 3, I have x minus 3 squared. Okay, there's a difference in the way I said that, right? Okay, so let's find the same exact things again. vertex, axis of symmetry, right, that's shorthand, and then the min or max value, and I'll just write that out when I get to it. Okay, the vertex. Okay, this time that's h, right? It's h. 3, not -3, right? 3. And then I can think about that as +0 on the end. So 3, 0. Axis of symmetry is x equals 3. Again, always coming from there. And then min or max value, okay, it's a positive in the front here, +1, so I know it opens upward, which means that my vertex is a minimum value. And it equals 0. Okay, let's do one more of these problems. Y equals 2, x minus 1 squared minus 4. Vertex. +1, -4. Axis of symmetry, x equals 1. Minimum maximum value, let me sketch the graph, just makes it easier to see it. 1, 1, 2, 3, 4. It's a +2 in the front, so it opens upward, making that vertex a minimum value. It's the lowest point on the graph. And the lowest value is -4. Okay, so these questions are not difficult, right? If it's given to you in vertex form especially, they are pretty straightforward. Okay, well, let's move on to the other type of quadratic equation. Again, there's really only one type of a quadratic. A quadratic is a quadratic, but there's different ways you can write out the function. Okay, so this one is typically called standard form or general form, depending on what book you're looking in. And it looks like this. ax squared plus bx plus c. Kind of important factor here though, a cannot equal 0. If a equals 0, you don't have a quadratic. Okay, that's because then this term would be 0 and it doesn't exist, right? So we wouldn't have a quadratic anymore. So I just want to specify that. We're dealing with a quadratic definitely here. Okay, and we did mention this in the last section. You know, this is a quadratic function. This is a standard form type function. Okay, I want to answer the same questions, but the vertex is not as easy to identify at this point. Okay, so how do I find the vertex? Well, we need to use this little formula. So vertex is negative, it's a point, negative b over 2a. If you think about the quadratic formula, negative b plus minus square root b squared minus 4ac over 2a. If I just isolated this piece right here, that's the x value of the vertex. Okay, that's the x value of the vertex. Now to find the y value, you take this number that you find, whatever it happens to be, you take that number and you plug it into the function. That'll give you the y value. And together, they'll give you the vertex. Now remember, if you have the vertex, then you have the axis of symmetry, right? X equals whatever this is. If you have the axis of symmetry, you have the vertex. If you have A, you know whether it opens up or down, at which case you know if you have a minimum or a maximum value. Okay, so all that can be found without actually having to graph it. All right, so let's do an example. I think we're on example 5 here. Okay, we have g of x equals x squared plus 7x minus 8. We want to find the vertex, the axis of symmetry, and so on. Okay, so we'll start with the vertex. Okay, like I said, the x value of the vertex will come from negative b over 2a. Negative b, 7, over 2a, that's 1. Okay, that's negative 7 over 2. To find the y value, I'll plug that in to g. Okay, and simplify that. So negative 7 over 2 squared is positive 49 over 4. 7 times negative 7 over 2 is negative 49 over 2. And then minus 8. Let's find a common denominator of 4. 49 over 4. Minus, okay, if I multiply this by 2 over 2, that's going to give me 98 over 4. Minus, if I multiply 8 by 4 over 4, that gives me 32 over 4. Okay, common denominator, so great. 49 over 4 minus 98 over 4 is negative 49 over 4 minus 32 over 4. Goodness gracious. It's going to be negative 81 over 4. All right, so that was the hardest part, finding that. Okay, I think that's right. You might want to double check me. Okay, so that's my vertex. My axis of symmetry then is x equals negative 7 over 2. Min or max value, well, A is the understood one in the front. It's positive, which means my graph will open up, making that bottom point the minimum value. And it will equal whatever the y value happens to be, which is negative 81 over 4. Again, I think that's the answer. Okay, so there you go. Sure, we had some ugly fractions, but the new part about that, right, the quadratic parts of the graph, parts of the graph of the quadratic function, there you go. That wasn't hard, right? That's pretty easy to do. Example 6. Okay, g of x equals x squared minus 5x plus 6, and I want to do the same thing. I want to find the vertex, the axis of symmetry, and yada yada yada. Start off with the vertex. Negative b over 2a. It's a positive 5 over 2. All right, well, here we go again. Make sure I have enough room here. Okay, so g of 5 over 2, trying to find the y value here. 5 over 2 squared minus 5 times 5 over 2 plus 6. 25 over 4 minus 25 over 2 plus 6. Common denominator of 4 again. 25 over 4 minus 50 over 4 plus 24 over 4. 25 over 4 minus 50 over 4 is negative 25 over 4 plus 24 over 4 is negative 1 over 4. Negative 1/4. Axis of symmetry. X equals 5 over 2. Okay, understood 1 in the front. It opens up. If it opens up, it has a lowest point, so it has a minimum value. And the minimum value will be the y value of the vertex, negative 1/4. Okay, let's do a couple more examples here. Okay, y equals x squared over 3 minus 2x plus 1. Oh, joy. Okay, so again, let's find the vertex. Negative b over 2a. I might want to rewrite this. Instead of x squared over 3, I'm going to write this as 1/3 x squared, because they're the same thing. And this way, at least I can tell that that's a. So negative b over 2a. Okay, so that's positive. Those 2's will cancel, so I'm really left with just 1 over 1/3. 1 over 1/3 is equal to 3, actually. You can see that as 1 divided by 1/3, which is the same as 1 times 3 over 1, which is just 3. Okay, so that actually kind of worked out nicely, right? The vertex starts off with a 3. To find the Y value of the vertex. Let's plug in 3. Okay, 3 squared is 9, so that's 9 over 3. That's going to be 3. Minus 6 plus 1. 3 minus 6 is negative 3, plus 1 is negative 2. Okay, although this one started off uglier, the vertex works out a little nicer. All right, the axis of symmetry. X equals 3. All right, understood positive 1/3, which means I know the graph's going to open upward, having a minimum value. So it's a minimum. And the y value of the vertex is negative 2, so that would be the minimum value, negative 2. All right, one more example, and then we'll be done with this. Okay, example 8, we have f of x equals negative x squared minus 8x plus 5. Let's find the vertex and everything else. So starting with the x value of the vertex, negative b over 2a. Let's take care of these negatives. Okay, those cancel out and left with a positive, but there's still a negative left over, so it's going to be a negative result. 8 divided by 2 is 4, so it's going to be 4 over negative 1, negative 4. Let's plug in negative 4. Okay, negative 4 squared is a positive 16. These two multiply together to be a positive, so 8 times 4 is 32, plus 5. So negative 16 plus 32 is a positive 16, plus 5. 16 plus 5 is 21. All right, so there we go. There's my vertex, negative 4, comma 21. My axis of symmetry, x equals negative 4. It's a negative this time, right? Understood negative 1 here, so I know my graph opens downward, right? Looks like this, which means that the vertex is now the tallest point on the graph. Tallest point. And if it's the tallest point, it is a maximum value. A maximum value of 21. Okay, there we go. That is a lot about the graphs of quadratic functions and vertex form versus standard form.